All right, these are the last 2 pages on the extension worksheet. We've got this graph here, and we're told that h of x is equal to the integral of f of t. So whenever you see this, it's always a good idea to just kind of right away say, hey, the derivative of h would be the derivative of this integral. Cancels, bring this in. In other words, this graph that you're looking at, this is h prime x, okay? That'll help you understand a lot of this. So the first one says, what's h of 6? So we can just do that by plugging it in. H of 6 would be the integral from 4 to 6 of f of t. Okay, in other words, what's the area from 4 to 6? And it's this triangle. It has a height of 3, a base of 2. 3 times 2 divided by 2 is 3. So h of 6 is 3. Okay. H prime 6, since h prime of x is f of x, h prime of 6 would be f of 6. In other words, where is the function at 6? And it happens to be at 0. And then h double prime of 6 would be f prime 6. So in other words, what's the derivative of f at 6? It would be the slope of this line. And this line went down 3 over 1, down 3 over 1. So we'd have a negative 3. When is h increasing? H is going to increase when its derivative, which is f of x, is positive. All right? According to this graph, this derivative is positive from negative 6 to 0 and from 4 to 6. Okay. Where does h of x have a relative maximum? That's when its derivative, which is f of x, switches from positive to negative. Okay. So if I look at my graph, I have a switch from positive to negative at 0 and at 6. So at x equals 0, x equals 6. Okay. Where does h of x have a point of inflection? That's when its derivative, which is f of x, switches from increasing to decreasing or decreasing to increasing. Because when the derivative is increasing, the original function is concave up. When the derivative is decreasing, the original function is concave down. So we have a switch here at negative 3, at 2, and at 5. Negative 3, 2, and 5. What is the absolute maximum minimum for this on this interval negative 6 to 8? So anytime we talk about absolute max or absolute minimum, we have to make a table of possibilities, okay? That table always includes the endpoints of what we're considering and any critical points. And those critical points are where our derivative equals 0 or is undefined. Since this is the derivative, this is 0 at 0 and at 4 and at 6. So we have to include 0, 4, and 6. All right, now we have to find these values. So again, the equation is written up as the area from 4 to wherever. So that means if we go 4 to 4, we get nothing, right? It's just 0. And we already found h of 6 on part A. That was 3. So let's find 8. You know what? I'm not even really sure where the 8 is. I'm assuming it's over here. So we'll do that. Okay? So now this triangle has a height of 6 and a base of 2. 6 times 2 divided by 2 is 6. It's below the x-axis, so it'd be a negative 6. So we're going to take this positive 3 minus the 6, and that's going to give us negative 3 here. Okay? So again, I'm just going from 4 out to 8 and figuring out that area. All right, now if we go back to 0, it's this circle. This has a radius of 2, so pi times 2 squared is 4 pi, but we only have half of it, so this area is 2 pi. And because we're going backwards from 4 to 0, we have to take the opposite, but it's below the x-axis. So this negative area takes the opposite, becomes a positive 2 pi. So at 0, we'd have a positive 2 pi. And if we go all the way to negative 6, now this circle has a radius of 3, so pi times 3 squared would be 9 pi. Take half of that, we get 9 pi over 2. And if I'm going backwards, I'm going to have to subtract that. So I'm going to take the 2 pi I had minus 9 pi. That's going to give me a negative 5 pi over 2. All right, now I have to figure out what's the biggest, what's the smallest. So 2 pi, 2 times something bigger than 3 is going to be a little bit bigger than 6. This is the maximum. Negative 5, negative 2.5 times something a little bigger than 3 would be a negative 7 point something. That's going to be my minimum. So the absolute maximum value of this is 2 pi that occurs at x equals 0. The absolute minimum is negative 5 pi over 2 that occurs at x equals negative 6. Not a easy one, but that's what you have to do. All right, then we get this table here, and it's a table for f of x, and we're asked to estimate f prime 8. So again, we're going to put 8 right there in the middle. To estimate the derivative, you just find the average rate of change. So it's 11 minus 9 over 9 minus 7, 2 over 2. We estimate that to be about 1. Use trapezoids and these 3 subintervals to approximate this. So if I do the first trapezoid, it'll be 15 plus 9 times the distance between them. The distance between 3 and 7 is 4 divided by 2. Okay. And the next one, I'm going to add those up. 9 plus 11 times the distance between them, which is 2 divided by 2. And then the last one, I'm going to go 11 plus 4 times the distance between them, which is 2 divided by 2. Okay. So this is going to give me 24 times 2 plus 20 plus 15. I'm going to get 83 for an answer. Okay. So now use part B to approximate the average value. So when we do average value, we say, well, what's the distance here? It's the distance of 8. And then we multiply that times the integral of that function from here to here. Well, we just approximated that as 83. So we're going to go 1/8 times 83, which will give us 10.375. That's our average value, or at least the approximate average value on this interval. What's the average rate of change? Well, now what we want to do is say, well, what was f of 11 minus f of 3? How did the function actually change? And then spread that out evenly. So f of 11, according to the table, was 4. F of 3 was 15. And so we're going to get negative 11 over 8, and we'll just leave it like that. And the last one is, what's the minimum number of extrema? So an extrema would happen if our function goes from positive, increasing to decreasing, or decreasing to increasing. So we look at our table here. We went 15 down to 9 and then back up to 11, right? So we went down and then up. Now, somewhere then between 3 and 9, we don't know where. Don't know if it's before 7, after 7, or right at 7. But somewhere in that 3 to 9 range, we'd have to have a relative minimum. So we would say 1 would be between 3 and 9. And then if we look again, this function goes from 9 up to 11, then back down to 4. So we will go from increasing to decreasing. So somewhere between 7 and 11. We'd have to have 1. We'd have to have a minimum here. We'd have to have a maximum somewhere there. So at least 2. We don't know. There could be lots more that actually happen for this, but based on what we see, we know there's at least 2 on that